All right, so test tomorrow. As I said yesterday, I'm just going to do one example of an integral, which obviously is not on the test. And then the rest of the time is basically like office hours. So you'll let me know what you have questions on. So let me start with the one example, which is from chapter 3. As I said, just to keep you in mind, because Monday is a holiday, so we're not going to have the next class until next Tuesday. So we did it quickly. Keep you in mind for next Tuesday. It's supposed to be a straight line there at the top. So let's integrate this function over the region bounded by y equals x squared and y equals 4. And so the first thing you would do is you find, oh, these are the points 2, 4, and negative 2, 4. So obviously it's not to scale. And the idea is, again, if I want to integrate something, which sort of is going to give me the volume. Actually, here it will, because everything's positive, so this will give me volume. It'll give me the volume under this curve over this region. And what we're looking for is, we're looking to integrate over the region of the xy plane. And on the inside one, we're looking at functions. What is the smaller function to what is the larger function? And on the outside limits, we want for what values of the outside variable that is true for. So here, since we're doing it dy dx, we're starting with dy. That means we're assuming that x is a constant. And so if you draw x equals a constant, you can see what smaller and larger mean. In this case is what is the lower function, what's the upper function. So here, what is the smaller function? So y equals x squared. And the bigger function is 4. And you can see from my picture that that is true from where to where? Okay, so let's actually do this one quickly. And then what I'm going to do is ask what happens if we reverse the order. So I made it dx dy. So made this one fairly straightforward on purpose. So first step is we're doing the inside integral, which is with respect to y. So what is the antiderivative of 6x squared y with respect to y? Partially. 6x squared and then times y squared over 2. So we're going to get a 3x squared y squared. Here you have to remember that we're plugging in for y. So if I put in y equals 4, I get 16, so I'll get 48 x squared. If I put in y equals x squared, I get x squared times x squared squared, which is 3x to the 6th. And when you're doing multiple integrals, after you do it with respect to one variable, that variable should be gone. So we just did the integral with respect to y. At the end of it, after we plugged in the limits, we have an integral without any y's left. In this case, since there are only two variables, it's just the one variable. And now we're back to a more basic integral. And I, of course, made it so it's nothing nice. So you get whatever 16 times 8 times 2, so 16 times 16, which is what, 256 or something like that. And then minus 192 over 7. So to a number. I'm going to be lazy since this is not on the test. So you get plug in the two numbers. So I'll at least do that. Wait, I'm not sure I'm getting 32. And whatever the number is. But let's do it also. So we can always do it whichever order we want. Sometimes one will be easier than the other, but we can always do that. So if I do it dx dy, so now I'm starting with x for the inside integral. That says I'm assuming y is a constant. So if I draw a typical y equals constant, now you can see smaller and larger are the left function and the right function. And here it looks a little weird. What is the, let's start with the upper one. What is the bigger or right function? Right, so it's the y equals x squared, so therefore it's x is equal to the square root of y. And what is the left function? Right, so the reason it looks a little weird is we have y equals x squared. If we solve for x, we get the plus or minus of the root y. And that is true for what range of y's? So from here to here, which is 0 to 4. So we can also do it that way. The difference is that after the inside integral, we'd be getting rid of all the x's, but the ultimate answer should be the same. So as I said, I just want to do the quick thing to keep it in your mind for next week. So any questions on this? So otherwise, test review. So you review with the answers. And even though it's fairly early in the semester, you probably already are aware that there are probably going to be some errors in the review. So if you find any errors, send me an email so I can correct it so everyone else gets it also. Usually, what I would do is go over ones that we haven't gone on over yet, but the only ones that haven't been on a quiz yet were the last couple, and we've been doing those last two classes, so I don't necessarily need to go over those. I did notice when I was writing up the answers, I was a bit repetitive. The questions are fairly similar. Sorry about that. So as I said, this is more now, from now on, it's more like office hours. So you're going to tell me what your questions are or what ones you want to go over. Similar idea. The review is quite a bit longer, I think. Although, I guess it's not too terrible, but the review is longer than the actual test will be. And as I said, you can kind of see where that might come in, which is there were 2 or 3 ones where I asked you to get the tangent set for a level curve. I think I asked that 3 different times. So obviously you're not going to get 3 different times tomorrow. But yes, so the same types of questions. In some ways, yes. Because, so as I said yesterday, if you want to see what a test looks like, you can look at the one from last summer because that will be similar length. So in some ways, looking at the test, so some of the types of questions will definitely be on there. So there will definitely be one where here's a function, find the critical points and classify them. There will also definitely be one where you're given a function over a region and you're asked to find the global minimum and maximum. So there'll definitely be one of each of those. I did, but I didn't put one on the review, so I think I'll leave it as what was on the review. So I forgot to put a word problem on the review, but so in theory there could be, but in practice now there won't be because I didn't put one on the review. And then from there, there'll definitely be a few where you're getting the gradient. There will be directional derivative stuff, asking which direction is it increase most quickly, finding tangent planes or tangent lines. And that is most of it, I think. So someone asked about number 8. So what I usually do is, except for things like 9 and 10, which are kind of a pain to redo, is I won't do the exact number 8 unless you have specific questions about it. I'll change the function and do the similar types of questions. So it has 1. So let's make it, and that is 2 variables. So let's stay with that. Let's make it a fairly simple one. And yeah, let me do this. Make it a 4 just so they're not the same number. So A is what you're going to be doing at least a few times in the test. Find the gradient. At 1, 4. Oh, yeah, that's one thing I was going to say. So for tomorrow, I will be on the Collaborate Ultra. You do not have to be. What it's for is that way if during the test you have questions, you can ask me questions. And if you have problems submitting the test, you can let me know about it and I can make sure it's okay or something like that. But yeah, so tomorrow you don't have to be here. So gradient is general as that. And as I'm doing this, since I just made it up, you'll let me know if I'm getting weird numbers here. So that's the first part. So B asks for the tangent line for the level set. So let's do it again. Find tangent line. And I'll put next to it kind of a B prime. So find the line for level set. These are all at 1, 4. So what would be the tangent line for the level set? Oh, I said just tangent, but that's okay. So in some ways similar to what we do for the plane, which is we use the gradient. Yep. So 49 x minus 1 plus 4 y minus 4 equal to 0. Okay. So I do a related question, which wasn't specifically asked, but comes up in part C. B was find the tangent line for the level set through the point 1, 4. B prime is find the tangent plane at the point 1, 4. So here, not for the level set, just for the three-dimensional surface. So to do this, we just need one little extra piece, which is what else do we have to get? Right, so we need to plug in the 1, 4 into the function, which is 17. And then the tangent plane is fairly similar to what I have here, except with the extra little piece. So the one little piece is that we add in the value of the function, and the other little piece is that we then set that equal to z to give us the three-dimensional part, the two-dimensional part. No, 3. And then CS, kind of a follow-up to this, which is, and let me just make up one, is the line xyz equal to 1, 1, 1 plus t 2, negative 1, 2, I guess. Say parallel to this thing. In this setup, so in this setup you have to add the function, but if this instead was, so that if the wording was this is x, y, z, and it was 4x cubed y plus xz, so now it's a four-dimensional thing, and you were asked to find the level set for the tangent plane, then it'll be like B. So if you're asked to find a tangent something for a level set, then you're using just the gradient. If you're asked to find a tangent something just at a point, then you have to use the method from B prime. So the level set part is what makes you use the formula in part B. And for the level set, you don't have to get the value of the function. And again, the reason for that is if we put it in, the level set would be 17 is equal to, and we take the derivative, the 17 would go away. Still 0. So the only difference between a tangent line for a level set and a tangent plane for a level set is that the original function, instead of having 2 variables, would have 3. And so you get something like 49x minus 1 plus 4y minus 4 plus 3z minus 2 is equal to 0. And if there were 4, which I'm not going to do, but if there are 4, you'd have the 4 variables still equal to 0. So whenever you're looking for a tangent set for a level set or a level curve, it's always going to be in this form where you have something on the left like what we have here and equal to 0. Whereas if instead you're getting a tangent set where you're setting the function equal to the variable, then it's always going to look like what you have in B prime. So to check to see if the line is parallel to the plane, what has to be true? So for the line to be parallel to the plane, what has to be true? Right, so the two vectors that go with the line and the plane have to be perpendicular. So here there's a little work to it. But what is the normal vector to this plane? And the reason it's the -1 is because to get it in the form that we need it in the form a times x minus something plus b times y minus and then plus c times z minus. So I need to bring the z to the other side, which makes its coefficient -1. And then this is the vector for the line. So it's a line parallel to the plane. That's the same thing is n perpendicular to L. And pretty obviously the answer to that is, so how do you check to see if they're perpendicular? Right. So you take the dot product. Pretty obviously it's not 0. It's 92 or something like that. So therefore, the line and the plane are not parallel. How do you check to see if two vectors are parallel? So this is how we check to see if two vectors are perpendicular. We look at the dot product. How do you check if they're parallel? Right, you need a scalar multiple. So for example, if I have 2, -1, 2, then also 10, -5, 10 would be parallel because it is 5 times the 2, -1, 2. And you would be checking that if instead I asked, is the line perpendicular to the plane? Because then their vectors would need to be parallel. So it kind of reverses because of the way they're set up. Any other ones that you have questions on? Or further questions on this? Okay, so for this, so let me bring over, make it even simpler. I guess I'll keep it about the same. And let me ask two related questions. And I'll call them both tangent sets, so I don't specifically say if it's a line or a plane. So if you look at the language, what it's saying is when I ask just for the tangent set at the point 1, 1, I'm just saying I have this three-dimensional picture, z is equal to x squared, y squared, whatever that looks like, and I want to find the tangent thing at 1, 1. What the level set terminology is telling me is, no, I'm not doing just that. I am fixing the function equal to whatever number I get when I plug in 1, 1. So in particular, here, it would tell me I have this function. So up here, for this one, I have this function. So I have a three-dimensional object, and I want to find a tangent set, which in this case will be a tangent plane, because it's one dimension. The tangent set will be one dimension less than the surface dimension. So it's 3 dimensions, so the tangent set will be 2 dimensions, which is the tangent plane. This one is a 2-dimensional object. So if I'm getting a tangent set, it'll have 1 dimension less, which will be a tangent line. So when I say level set, what I'm saying is I'm fixing the function equal to a particular value, which means I'm getting rid of 1 dimension, getting rid of 1 variable. And the other difference is in how it's set. So for example, at the end of this, what I could get is a tangent line for y in terms of x, because I only have 2 variables. In this one, I want to get the tangent plane for z in terms of x and y. So notice in the first one, I have z as an explicit function of x and y. I'm going to do it one way, whereas in the second one, y is a function of x, but it's implicit. So what I'm going to do is take the derivative of both sides to get the gradient type thing, which is why the 1 is going to go away. Okay, so the level set is fixing it. Right, so I did. Right, so this is a level set, so I set it equal to 0. This is not a level set up in the first part. It's just a tangent function at a point, so we're not fixing the function. And so, yeah, we don't set it equal to 0. Notice, if we wanted to, we could make the first one similar to the second one, which is I have this function z is equal to x squared y squared. If I subtract the z to the other side, now I do have a level set, and I can get the gradient, and I can use the formula for these the way I do the second one. And obviously, it better be the same thing. And so here you can kind of see the difference, although it's a fairly simple version. This is z as a function that is explicitly a function of x and y. Here, z is still a function of x and y, but now it's implicit. Yeah, I've been solved for z in terms of x and y. Okay, other questions? I should say this is kind of a typical question, although the amount of questions about it is not quite equal to how much it's going to be worth on the actual test, but that's okay. So any other types? Well, because that's what we need, right? So in this one, if this is a plane, it's pretty obvious that's what we need, right? Which is that to get the equation of a tangent plane, you need the normal vector. Usually we don't think of it that way in terms of a line, but this is a line written in the same way, which is we're writing the equation of a line using a normal vector. So usually we get the equation of a line using a vector that's parallel, but you can still use it with a vector that's perpendicular if you write it like this. So it's just, it looks a little weird here because we're writing it, the line using a slightly different method. Any other questions? I've looked at a couple of them quickly, and in theory, yes, which is, and anyone else can answer this, which is when I go in, if I right-click on your score, it will, I forget which option, but one of the options is I can look at it, and it won't show me your quiz, but it'll have a link to it, which I can click on to look at. And then there's a little discussion box where he has put in comments such as 2a -1 arithmetic wrong or something like that. So there should be, if you go in there should be comments for the questions where we got points off. I think I said this after the last quiz also, which is if you do have questions about in one of two forms, either why a certain number of points is taken off, or you just don't see it. If you email me, I can look it up for you. I can check to see if I agree with that with the TA, and send you my comments. So in general, if you have either trouble getting to the comments, seeing what they are, or you don't agree with them, send me an email and we can talk about it. And in particular, it might not be a bad thing for you to do that during, for example, office hours, because then we can actually really talk about it instead of going back and forth with email. Which brings up, as we're waiting, so remember that before the test tomorrow, the TA does have office hours today. The link is on Blackboard under one of the announcements, under, I think, a Zoom session. And I think it's 3:30 to 5 today. And then tomorrow I have my usual office from 11 to 1. And the Zoom link for that is also on Blackboard. So if you have more last minute questions, stop by at either of those two. Other questions? This is the way it usually is on test reviews. In theory, in some ways, the reason I do test reviews is just to give you a day off to get ready for the test, because you already have the answers. I know after the last quiz, so actually let me stop recording because most people don't really need to hear all this stuff.